All right, today we're diving into a field that sounds like it's straight out of science fiction, but it's actually reshaping our world right now. We're talking about biomedical engineering. It's where biology and machines meet, and believe me, it holds the keys to the future of our health. Let's get into it.
I want you to just think about this for a second. What if the answer to our biggest health problems isn't found in a pill bottle, but built in a lab? What if it's a smarter material or a new piece of tech? That's the powerful idea we're going to be exploring.
So what are we actually talking about here? What is biomedical engineering? Well, think of it as the ultimate team-up. You take the incredible problem-solving power of engineering and you aim it directly at the super complex human body. The goal? It's simple, but man, is it profound? To engineer brand new ways to improve our health and our lives.
Okay, first up, we're going to look at how we can literally rebuild the human body. This is where biomedical engineering gets really hands-on, tackling some of the most visible and frankly life-altering challenges people can face.
You know, the challenge here is deeply personal for millions of people. A part of your body is lost, or it just stops working the way it's supposed to. But an engineer looks at that and doesn't see an endpoint. They see a problem to be solved. If you can't fix the original, well, you just build a better replacement.
Let's take a classic example that you've probably seen: prosthetics. But forget what you think you know. We are light years beyond simple replacements. I mean, today's advanced limbs can actually integrate with a person's nervous system. We're talking about a level of control that doesn't just restore mobility, it restores a sense of wholeness. It is the perfect example of engineering changing a human life.
Now, replacing a part is one thing, and it's amazing. But what if we could take the next giant leap? What if, instead of adding an external device, we could actually convince the body to heal itself from the inside out by growing entirely new tissue?
And this is where we enter the incredible world of tissue engineering. It kind of breaks down into 3 steps. First, engineers build this special scaffold. You can think of it like the frame of a new house. Then, they take the patient's own cells and seed them onto that scaffold. Finally, in a lab, those cells multiply and grow into new, living tissue that can be put right back into the body. This is the very foundation of regenerative medicine.
But listen, none of this works without one absolutely critical idea: biocompatibility. You can't just stick any material into the human body. Our immune system is literally designed to attack anything foreign, so the material has to be engineered so precisely that the body accepts it, like a key fitting perfectly into a lock. It's that biological handshake that says, hey, welcome, you belong here.
So we've seen how engineering can rebuild us from the outside, but what about all the problems that start deep within? To fight those, you first need a really clear view of what's going on inside.
I mean, one of the biggest challenges in all of medicine is diagnosing the invisible. Things like cancers or neurological disorders, they often develop silently, and the key to treating them is always finding them early. So the question is, how does engineering help us see what the human eye just can't?
Well, the answer starts with advanced medical imaging. We're talking about technologies like MRI, CT scans, and ultrasounds. These are our powerful, non-invasive windows into the body. They let doctors see with stunning clarity what's happening, all without ever making a single cut.
But those images, they produce an enormous amount of data. And that's where we can add a supercharger to the whole process: artificial intelligence. AI has taken diagnostics to a completely new level.
And its impact is huge. For starters, AI algorithms can analyze all those complex scans and spot tiny, subtle patterns a human eye might miss. That means earlier, more accurate diagnoses. Then, in the operating room, you have AI-guided robotics that can help a surgeon with incredible precision, which means better patient outcomes. It's all about making our medical tools way faster, smarter, and just better.
Okay, for our final section, let's look ahead. This is where the line between what's possible today and what's coming tomorrow gets really, really blurry. We are exploring the absolute cutting edge. And this is where we see a huge shift in how we even think about healthcare. We're moving away from a reactive model, treating sickness after it shows up, to a proactive one. The goal isn't just to cure disease anymore. It's to predict it, prevent it, and then personalize the solution just for you. This future starts with data. Those wearable biosensors, think your smartwatch but on steroids, can track your vital signs and health metrics continuously, in real time. And this isn't just about counting your steps. It's about having a constant stream of your personal health data that can predict a problem long before it ever becomes critical.
Next up, and you might want to sit down for this one, 3D bioprinting. Yeah, you heard me. Forget printing with plastic. This is about using living cells as the ink to create functional tissues and, one day, entire organs on demand. The implications are just staggering. Imagine a future with no organ donor waiting lists.
And finally, all of this data, all this technology, it all leads to personalized medicine. It's the end of the one-size-fits-all approach. By understanding your unique genetic makeup, your DNA, doctors can design treatments and prescribe medications specifically for you. That means maximum effectiveness with minimum side effects.
So when you put all of this together, what's the ultimate goal? It's a true revolution in care. We're talking about tailored treatments for every single patient, diagnostic tools that are faster and more accurate than we ever dreamed, and at the end of the day, radically improved outcomes for people everywhere.
And look, this isn't just some theory for the future. It's happening right now. The source material puts it perfectly. Biomedical engineering has significantly transformed healthcare, improving quality of life. It's already solving some of our biggest medical challenges.
So from the prosthetics we can see and touch, to the AI that can see what we can't, all the way to a future of organs printed on demand, biomedical engineering is actively building a new, better, and healthier reality for all of us.
And that kind of leaves us with one final, pretty profound question to chew on. As engineering and biology continue to merge together, what will our very definition of being healthy even mean in the future? It's a fascinating thought, and it's a future we're all going to get to see get answered.